Gerald J. Sussman's talk, we really don't know how to compute, kind of cheered me up in a kind of sick way. Um, that was 2011. And I was thinking about the system, that the structure and interpretation of classical mechanics system was relied on a non-standard extension to, I think it's MZ scheme that they use. And one of the big motivations I had for trying to learn to use functors and things properly was in standard ML, was because that structure and interpretation of classical mechanics stuff is really hard to use because the compiler can't type check. You can write code, and then you'll get a runtime error. You've taken car of nil or something. That's how your type errors come out. Car of nil, right down in some function that was supposed to be multiplying two vectors, but you got the dimensions wrong, and it doesn't work. It's nice once you've got your program working, then you see it works all the time. But there's a great leap forward to be made by being able to type check that stuff at the top level, not at the not right down in the depths of the mechanics, and I mean the computational mechanics. And there's some wild stuff that you can do with lists in standard ML if you use a recursive data type with two what it is a smarter way of pairing. I don't know if it's smarter, but it's kind of more symmetrical. It's only a convention that car is the first, or the left-hand element of a pair, and kidda is the right. And I played around for on and off for weeks with data structures, and I found one that looked like it would have some use in maths, in tensor calculus. It made a distinction between a left list and a right list. So it was a recursive data type that had two different directions you could go, and if you alternated, you could actually have types. You could use polymorphic types on arbitrary dimensional arrays. You didn't have to decide where this thing kind of bottomed out. it was nice. There's potential there. Unfortunately, I lost. I wrote somewhere. I wrote about it. I'm not having new ideas here. All I'm doing is, it's a pretty painful process of trying to. I'm just recovering little dried bits of thought that I had in Bolivia. The experience that I'm having now is very different to the experience that I had when I had a machine and I had the time to do this stuff. What I'm doing now is just archaeology. But it seems to me that there's some real convergence been going on, and it was going on long ago. I saw Gerald de Susman at Cambridge once. He came. I think he's friends with. I can't remember his name. But and after that, I thought, I could email him, because I couldn't get past exercise 13 of structure and interpretation of classical mechanics. I just couldn't do that. There's one crucial theorem of Lagrange minimization and generalized coordinates, which there didn't seem much point in going on if I didn't understand that, and I never did understand that. I wrote to him, but I didn't get a reply. Or maybe he did reply, and maybe, I don't know, maybe because I was in Bill Gates' jail, I wasn't allowed to read the reply. Project Swiss, this is the way forward. Heavily armed and neutral. And it's interesting that people involved in the ISO Open Systems Interconnect model they talked about 2 extra layers on that interconnect, one which was political and one which was economic. And it seems like those are the ones we should have been working on. ASN1 is just an abstract notation. It doesn't specify anything about the concrete representation. And there's another language. I can't remember the acronym, or I can't even remember the name of the it's a language for specifying concrete representations of the elements in your ASN1, and It's the kind of language that from which you can automatically generate code, and the people who developed those standards ran into theoretical difficulties with computability in verifying that a given concrete data structure was capable of representing faithfully the ASN1 structure. You ideally want a tool to verify that, and they managed to convince themselves that this was theoretically impossible because of problems of, something like I can't remember the name. The name of the theorem about figuring out what a program is doing. But I had fun in 2014 playing around. I was just playing. I was trying to get the Guile developers interested in stuff, and so one of the interesting bits of the Guile scheme implementation is it's designed to run as a library within another program. And so what I was aiming at was my Red October thing, was getting Moscow ML to run in the same way as an embeddable programming language on the same standard as Guile's. Can't remember what they call it. So you could actually have them both. You could have them both. You didn't have to choose which would be your top level, standard ML or scheme. And I managed to get exceptions thrown in one. I managed to get something working with throwing exceptions from one language to the other, and it was quite interesting. But it kept breaking. I had to modify the Guile had a whole lot of. They did a lot of work to try and get get some of the semantics of Lisp, with the idea of using Guile eventually as the Emacs language. So there was Lisp semantics with, what do they call them? Can't remember. But I stopped watching Gerald's video at the point where he started talking about the economics of programming.